Think about how most objects are made by carving material away from a block. 3D printing flips this script, using additive manufacturing to build objects from nothing. Instead of cutting, we build by adding material one tiny slice at a time. This layer-by-layer construction allows us to create incredibly complex shapes that were once impossible. Every print begins as a digital blueprint. These 3D models are precise mathematical representations of an object stored in a computer file. To make these models printable, we use slicing software. This program dissects the digital model into hundreds of horizontal layers, calculating exactly where material must go. Software then translates these slices into G code. This is a specialized command language that tells the printer exactly how to move and how much material to extrude. To execute these commands, the printer relies on specialized hardware. The primary components include the print bed, which provides a stable foundation, and the extruder, which manages the material. This movement is driven by a precise motion system. Stepper motors rotate in tiny controlled increments, pulling rubber belts to position the print head with extreme accuracy. While we are focusing on extrusion, many different printing technologies exist. Each method uses different states of matter or light to build objects. The most common method is fused deposition modeling. This process works by feeding a continuous strand of thermoplastic filament through a heated nozzle. For the plastic to bond, the nozzle must reach precise melting temperatures. This heat allows the thermoplastic to become fluid enough to be extruded smoothly. The position of your print depends on these settings. The extrusion width determines the thickness of each line, while layer height controls the vertical resolution. To ensure the object stays put, the print bed must adhere to the first layer. Proper adhesion prevents the edges from lifting or warping as the plastic cools. As each new layer is deposited, cooling fans blow air across the plastic. This rapid cooling is essential to solidify the material before the next layer arrives. When printing complex shapes with overhangs, the printer creates temporary support structures. These sacrificial scaffolds hold up heavy sections until the print is complete. Inside the object, we use infill patterns and density. A higher density provides greater structural strength, while sparser patterns save time and material. To ensure success, the printer uses real-time sensors to monitor temperature and movement, allowing for constant calibration and quality control throughout the build. When things go wrong, troubleshooting common issues like nozzle clogs or bed leveling errors is essential to getting your project back on track. The choice of material is critical, as different thermoplastics offer varying levels of flexibility, heat resistance, and overall durability for your final part. Once the print is finished, post-processing techniques like sanding, polishing, or removing supports are used to achieve a professional surface finish. From digital design to physical object, additive manufacturing transforms data into reality through a precise layer-by-layer journey of creation.